All right, guys, and we are continuing on our CLT math practice. Moving on to question number 87. We see what is the third term in the following sequence? We have 1 over 4. Then we've got our question, so it's going to be one of these numbers. 1 over 16, 1 over 25, 1 over 36. And if you'll remember in class, I said there's a series of numbers that I want you to memorize or be familiar with looking up quickly and think about it. What were those numbers? If you have your yellow packet, we wrote it at the front with our formulas. When we look at the denominators, we've got 1 would be 1 over 1, right? We got 1, 4, we don't know, 16, 25, and then 36. So when you look at these numbers, what do they have in common? What would make sense in the box? 9, 10, 12, or 14. If we look at these, you should see, hint, PS, you should see that all of these numbers are perfect squares. So 1 is 1 squared, 4 is 2 squared, 16 is 4 squared, 25 is 5 squared, and 36 is 6 squared. So what's missing? 1, 2, 3 squared, 4 squared, 5 squared, 6 squared. We are missing 9. So we've found our answer. You may see perfect squares come up in a different format than this on the CLT exam, but I've seen where we've used these perfect squares in multiple practice test questions, so be prepared for that. Number 88, which of the expressions below is equivalent to 12x y squared z to the power of 6 plus 3x squared y to the power of 4 z to the power of 9. This is a bit more complex than what we have seen on SAT, ACT, or your algebra EOCs, but it's totally doable. So we have the monomial outside of the binomial over here, and these are in parentheses telling you to use the distributive property to multiply across here to get back this, right? So which one of these down here is a match? The first thing I see is that these all have a 3 at the front, a 4 as the first thing inside of the parentheses, and then our invisible sneaky 1 as the back thing inside of the parentheses, which all of the whole numbers are a match. So I'm not going to focus on the number portion here because they're already all the same. They're all a match. So what I need to focus on then are my x, y, and z variables inside of the polynomial here. So the first one, if I multiply x times no x, I get this 1x. And x times x, I get this x squared. My x's are good on A. My y's, I got y times y is this 2y. And this y times y to the power of 3 is y to the power of 4. So my y's are a match. And then z, I have z times z to the power of 5 is z to the power of 6. And z times z to the power of 6, which is z to the power of 7. It's not z to the power of 9. So my z's are out on option A. So I'm going to move on quickly to option B. X times no x is a plain x. Y times y is y squared. Z to the power of 3 times z to the power of 3 is z to the power of 6. So my front is good on B. And now let's check the back. X times x is x to the power of 2. So both of my x's were a match. And then y times y to the power of 3 is y to the power of 4. So my y's are both a match. And then z to the power of 3 times z to the power of 6 is z to the power of 9. So my z's are a match. And that is my correct answer. So I'm going to move on to question number 89. The line x equals 3 is reflected over the y-axis. So first of all, I'm going to draw my x and y-axis. What is the resulting line? Now I'm going to graph this line, x equals 3. So when x is positive 1, 2, 3, there should be a straight line, straight enough, x equals 3. And now it's saying that this is going to get reflected over the y-axis. So if this was a piece of paper instead of a computer screen, I could fold my piece of paper in half on the y-axis, and that would move the reflection of x equals 3 to about right here to be x equals negative 3. And that's our answer. Number 90. In the diagram below, both circles have a center at A, and point B is the intersection of line segment AC with the smaller circle. So A, B, C, they're all on the same line segment here. If AB is 4 units long, so from here to here is 4, and BC is 2 units long, so from B to C is 2. What is the difference in circumference between the larger circle and the smaller circle? So first of all, I'm going to focus on that word difference. Difference is a key word, and that is the answer to addition, subtraction, multiplication, or division. Difference is the answer to subtraction. So this keyword is telling you to subtract the circumference of the large circle minus the circumference of the small circle. I'm going to use another color. And circumference. If that is something that you don't have memorized, your formula for circumference of a circle, I want to show you really quickly where to pull this up in the test, right? While you're taking your test and you come across this question, you see, circumference, you click on your formula button, and it's right here. The circumference of a circle is 2 pi r, where r is the radius of the circle. So I'm going to write my formula underneath each one. 2 pi r minus 2 pi r. And all I need to look up is the radius of each circle. So my large circle goes from the center all the way out to C. That's 4 plus 2. So that's 2 pi, and my radius 6 minus 2 pi r. Small circle, where my small circle goes from the middle to point B, and that radius is 4. So 2 pi 4, and we're almost there with this question. 2 times 6 is going to be 12 pi, minus 2 times 4 is 8 pi, and very last step, 12 minus 8 is going to give us 4 pi.